Hi, I'm Russ with Delaney Drafting and Design, and in this video I wanted to go over some basics on how to use a voltmeter. Now I'm not a licensed electrician, and this is not an exhaustive course on this. This is just to help people who are just getting started, and also I walk people through a lot of troubleshooting, diagnosing, repairs on the phone, and this might help them with actually doing that, especially if it's the first time that they're doing it. So if you haven't seen my video on choosing the right voltmeter, you might want to watch that one first. But what I've done now is I've just kind of whittled it down to my favorite two meters, and we're going to get into showing you the basics. And again, this is just total basics on using a voltmeter. Now, you might look at a voltmeter like this and get intimidated at first looking at all these different symbols on here, and you just don't know what it means or how to start. So first off, what we're going to do is, again, I'm only talking about simple troubleshooting here. So all we're talking about really is testing for voltage, testing for continuity, and also checking ohms and resistance. There's other things that you can do with the voltmeter, but that's all I'm going to get into right here. So it's important to understand that, first off, the symbol for voltage is just simply a V. And that's easy enough. The amperage is an A, and that's also easy enough. So when we branch into the different types of electricity, we're going to see that there's alternating current and direct current. So when you see the symbol on the voltmeter, like the first one here, it's V, and it's that up and down. It's actually a sine wave, but it's like a squiggly kind of line going up and going down, back up again. That's because alternating current does that. It alternates back and forth. So that is the symbol that you see here. That's the first symbol, and it's the most common one used is the AC volts setting. So when you're checking for DC, that symbol is, rather than it being that sine wave, it's a straight line and then a dotted line. So you see, with AC, you have a hot and a neutral, and the current is going back and forth. And with DC, you have a positive and a negative, and that's why they have these symbols like that to represent the positive and the negative. Positive being the red and the negative being the black. A lot of times in your AC circuits, your black is the hot and the white is the neutral. So anyway, those are the symbols that they use. So you see, here, the first one is volts, AC, and then millivolts, AC, and the next one is volts, DC, and then we're going to get into, this is ohms for resistance, and then the next one is actually continuity. It looks like a symbol for a bell. And for beginners, again, I don't recommend that you get into anything after this. You might not even understand diodes and capacitors, and this is pretty kind of tricky stuff again. The amperage settings here, I wouldn't mess with. Usually you need to have your leads in a different configuration down here in order to check for the amperage. If you're having amperage issues, I really recommend using an amperage meter like this. This is an inductive clamp style meter, and you just simply wrap it around the one wire that you're checking the amperage of, or you use a line splitter like this to actually read the amperage. Meter like this, you're actually putting the meter into the circuit, and there are fused spots for protection, but still something that I would stay away from. We're only going to be discussing volts through continuity. So your continuity again is like a bell type of a symbol, and when you set your meter to continuity, then what you should basically, here we go, this is 200 kilo ohms, and then this is a 2000, this is ohms and continuity. So what they're doing is, when you touch these two together and there's a direct short, it beeps, and it's showing you about 0 on the display. 0 resistance means that there's electrical continuity flowing through. Sometimes you want that in the circuit, and sometimes you don't, and that's basically how you test for that. So if you do not have continuity with a bell on your meter, then you have to switch it to ohms, And when you're measuring, which is, resistance, that's the symbol omega, and it's kind of like a horseshoe. Now, when you're testing for that, you don't have continuity, you don't have a bell, then you need to just simply, when you're probing on the circuit, you're checking here like this. If you were to check for electrical continuity again, if you don't have a beep, then you're going to have a 0 on the display, and that tells you that there's 0 resistance. So that's a direct short. So again, just quickly, that's the symbols that this is pretty universal. You're going to see this on pretty much all of your different voltmeters. So that's what you would need to know. Again, voltage, amperage, this is alternating current, direct, and then the continuity bell, and then the ohms or resistance is that omega. So let's get into testing. I'll give you some examples here. I'm going to hook up. This is a circuit board and needs repair. And let's see. Right here, this is your input terminals. So that's where you have 120 volts coming in. Now the way that the circuit is wired is this is a 120 volt transformer. And then you have these are the two primary terminals, and you see the first thing that they're doing is we're going to provide power into the timer here. There's a fusible trace right here where it comes off of this terminal and goes to one leg of the transformer, and then you see this one here goes to these two legs of the transformer. Now I know that this transformer it has a 120 volt primary. There's 120 volts set to come in here. And then here are the secondary terminals. This is where it should be putting out about 13 volts, but it's actually AC in this circuit. A lot of times your transformers will step it down from 120 volts to 12 volts DC, but I know that this is supposed to put out AC at a lower voltage. So what I'm going to do to test this is I'm going to hook up, I have an electrical fixture here, where, let's see, this is a neutral and that's a hot. So I can hook up the hot where it's supposed to be, and then the neutral here. And then I'm going to be probing at these terminals. I'm going to get my meter ready, and I'm going to set it to volts AC. Okay, so if you can see the voltmeter, this is normal for it to dance around. It's 0 something, and it's very, very low. You can just treat that as 0. Now I'm going to turn this on here, and then I'm going to probe here at those primary terminals where it comes in. Now it doesn't matter which of these I use. In a DC circuit, yes, it would matter. You have to put the red on the positive and the black on the negative. But this is an alternating current circuit, so if you see, if I put the leads here on these two spots here, the voltmeter there reads 121. That's 120 volts. Okay, now what I'm going to do is I'm just going to switch it around just for the sake of it. And it still says 120 volts. So if you do that on a DC circuit, then it's going to give you a positive or a negative if you, based on the polarity of how you have it connected into the circuit. So that's the power coming in, and then again, this is the transformer here. We can test the two terminals on the transformer here, and we see that the transformer is getting 120 volts on the display there. And now I'm going to move to the secondary terminals of the transformer, and then we see it's putting out 12.5 volts AC. So the transformer is working good. Now, let's say that we want, again, to check for just simple electrical continuity. Again, with this type of a meter, if we switch it over to ohms and we touch the two leads together, we see that it's just about 0 on the display. So that is obviously your electrical continuity right there, no problem. And then here, this meter has a bell for that as its own function right there. So that way you can do it without having to look at the display. Every time that you're touching two things that are electrically equivalent, then it will beep. On this circuit, this path right here is also consistent with this Well, you see it goes all the way through from this terminal to that terminal there. So if I touch one lead here and touch the other there, you hear a beep. So there is electrical continuity all through this path here. Sometimes you check it from the end of one wire to another. You know, like if you don't know if there might be a break in the wire. Say, for example, because you need to be able to make sure that the voltage can go through from one place to the next. So if we touch the metal part here on the inside of that terminal there, and then we touch this one here, see, we have the continuity right there. So if for some reason you check two different ends of the same wire and there was not electrical continuity, that would tell you that the wire itself is bad. Now what we're going to do is we're going to switch it over to volts DC. And here I have a DC power generator. And I'm just going to take, this is the black and this is the red, so I'm just going to make that match and touch the metal parts in there. And you can see on my meter, it's giving me the, it's about 12 volts. And then here, I'll show you if I reverse it. See, it's giving a negative. So it's telling me basically I have them reversed. If I have it correct though, and it's reversed, then that's telling you that you have a problem with your polarity on the circuit. But what you're going to see here is the device says it's putting out 12 volts, and that's what the meter is reading. So I'll change it, and then the meter should change accordingly. Now it says 18.1 volts, and that's what we're reading. And again, this is DC now that we're testing, the direct current. If I switch it to AC, and I try to test it, see the meter's jumping all around. If you see this happening, that's telling you you're not doing something right. It's trying to read AC and you're giving it DC. So again, you switch it over to the DC and it's reading just fine. And it's reading what it should be. Here I crank it up all the way, 27.8. It's off by a little bit, but it's close enough as far as that goes. But yeah, that's the basics really on using the meter. There's, on this one, you do have a millivolt setting, but that's just lower range. You might see this on some meters, like say this one here. When you go to use it, you might be confused because it says DC volts, and here's 1,000, 220. It's like, well, what do you put it on? Well, what are you expecting to see? Are you expecting to see 100 to 200 volts? Well, then maybe put it at 1,000. Or if it's only 120 volts, well then you put it in the range of 200. This is the max that you're going to be reading, so you're just putting it into that range. If you put it into a range and it says OL, or if it's not reading properly, then crank it up to the next higher range, and then it should probably read okay there. Same thing here, the AC volts, you have 200 and 750. You know, so maybe just start at the highest one and then bring it down, you know, from there. But again, if I think OL is like overload if you're going too high out of the range that you're picking. So that's the only reason why you have multiple sub settings on the voltmeter. So I hope that was been helpful for you. Thanks for watching the video. If you liked it, please like, comment, and subscribe.